Continuing, we'd like to talk about some of the newer features in Maya, the profiling, debugging tools that Autodesk has put into the system in the last few years. That starts with the Digi Profiler, the Mel Profiler, and a tool that really isn't something they actually put in, but kind of comes for free with the Python system, or the addition of Python scripting in Maya, is the Python debugger. We'll be going over these topics now, starting with the Digi Profiler. The Digi Profiler captures node metrics much the same way as the Digi Timer does. It captures the node time as a percentage of runtime, the number of computes per node that are in your scene, the compute time per node, the compute inclusive time, and the dirty inclusive time in the scene. The plugin is available. The Digi Profiler is a plugin, and it is available in the past few versions of Maya, like I indicated before. It is available to launch in the plugin manager. You should see in the plugin manager the Digi Profiler, and just activate that by loading or auto-loading the plugin. And once you have done that, the plugin or the Digi Profiler menu will be accessible from the window pull-down under General Editors, Digi Profiler. Once you've done this, or clicked on those buttons, the Digi Profiler will pop up a spreadsheet style interface that allows you to analyze your scene file inside of Maya. This is what it looks like, and we'll be going over that in a moment. The other type of profiler that they have added is the Mel Profiler. This is a plugin available in the past few versions of Maya as well, and it actually captures metrics for the script nodes, script callbacks, script jobs, and any Mel script that you may actually like to profile. Here again, since it is a plugin, it's available under the plugin manager to load, and its plugin is called the Mel Profiler, and you just want to load or auto-load that as you will. The script editor is available, or I'm sorry, the Mel Profiler is available under the script editor command window, under the command menu item, launch Mel Profiler. And that will pop up a window that captures the percentage of runtime, the time of a proc, the number of calls to that proc, the total time that it takes to compute, and the average call time, as well as the location on the file system where that procedure or proc is located. The Mel Profiler window looks like this. It's a spreadsheet much like the Digi Profiler. And what we'd like to do now is to give you an idea what they look like and how they operate. Here we have the Mel file that we have been using in the previous section. It's our little city with the our little robot in the city here. Little robot. What we're going to do here is we'll start with the Digi Profiler. Go under Window, General Editors, Digi Profiler. Open up the spreadsheet for that. And let's go over this interface a little bit. You'll see at the top there is a profiling menu. Underneath this you have a profiling button that actually launches the profiling process, capturing the data and then displays it to the window. A filter node option that allows you to filter out particular pieces of information in the window or the spreadsheet. An option to graph the selected node, as well as saving the profile data that's actually in the spreadsheet. So basically what this does is it'll go through and save your captured profile data set to disk so that you can actually look at it in an external spreadsheet or some other system that you may want to use to analyze the data. There's also a option here to reset the data that's in the spreadsheet so it starts clean. Okay, I want to go over a couple of the other items in the bottom of the window here. Here is where you can specify the node type to filter by just typing in the node type and enabling that function. You also have the ability to highlight the entries that consume more than a certain percentage of runtime. So right now by default it's set to 0. So if I want to capture or tell it to highlight compute processes that take longer than 10% of runtime, I can enable that, and I'm going to do that right now. The next option down here allows us to specify to the profiler how many times we want it to run through this frame range that we have set up here. Right now, for the sake of time, I'm going to run it through once, but you can run it through as many times as you want. So once you have all this set up, all you need to do is click on the profile button, and Maya will go through and run through the frame range right here, capturing all the data, and then it will display it in the profiler window. As you can see, there's a bunch of nodes here. I'm going to open up this spreadsheet a little bit so that we can see some of this data here a little bit. The first column gives us the node names, or the name of each node that it captured the data for. The next column is our percentage of runtime, basically how much of the overall percentage of runtime this node took to compute. The next column is the node type. In this case, the first one is an animation time linear curve. That's what the TL stands for. The next column is the number of computes in this cycle, in this number of runs. The next column is the compute self time, basically how long that node took to compute, and this is in seconds. The next column is the compute inclusive time. Again, this is in seconds. And the last column is a dirty inclusive time, or the amount of time it took to compute or figure out the state of all the plugs, the dirty state of all the plugs that are on that node. Okay, since we highlighted entries that took more than 10%, we see that there's a couple items here that it highlighted. Most notably the GunBot Expression 1 node. This actually is telling us it took 37.2% of our runtime, which pretty much indicates this is the most expensive node in this particular scene. Since it's an expression node, we already know basically expression nodes take up a lot of time to process. So the best thing that we could do to actually go through and speed up this scene, if we wanted to speed it up, is to try to figure out a way to remove this expression node. Right now, this expression node is actually being used to compute the animation of this character. The only thing that's animated on this character are the feet, and the expression is used to compute the position of the root node. The body of this character and the way the hips move. So it's actually doing quite a bit. So for the sake of this presentation, I'm not going to actually go through and remove this, but that would be one thing to look at. The other node that seems to be quite compute intensive, taking 17% of the runtime, is this transform node. That's actually the root node of the GunBot that I was just referring to, that gets fed all the animation from this expression. So as you can see right here, Maya tells us or gives us the information to help us analyze the way this scene is operating. We can also actually select each one of these nodes. Like for instance, I'm selecting the expression node, and I'm going to tell Maya to graph that node in the hypergraph. This is the connection mode, and it literally does just that. It graphs that for us so we can actually see the hookup of this node and all of its dependencies. The other thing that it works nice within Maya is to be able to tell it to show the heat map for this dependency graph, and it will literally tell us, by color, what in the dependency graph, what is taking the most amount of time to compute. And as we already know, the expression node is taking the most amount of time, so it's colored red. And the ones that take the fewest amount of times are in blue, and the least amount are just not colored at all. We also see that this node here is, which is our root node. As we select it, we can see it's our root node, is taking the next amount of time within our scene. So the heat map is just that. Colors that are red are the hottest or the most intense compute intensive nodes that are in your scene, and as they get cooled off, they turn blue and just basically turn off altogether. So here again, this just verifies that in this particular scene, this expression node is our culprit in this particular scene. The next profiler window, well, before we go on, we're going to go to this, just show you how the reset button works. Once you hit the reset data button, it just clears out the spreadsheet, removes all the data that was stored in memory for that, and then allows us set up to do another run. What we're going to do now is actually go ahead into our script editor, and I'm going to switch this lower panel here from the hypergraph to our script editor, going under Panels, Script Editor, and I'm going to turn on our Mel Profiler. Here again, it looks much like the dependency graph profiler and the view that we saw in the slide earlier. In the main menu here for this window, we have a profiling button that allows us to start and stop the profiler, as well as profile a particular procedure, profile a script file, profile or save the profile data itself out to a disk, and to save the call graph data, as well as reset our data. So what we're going to do is start the profiler. I'm going to hit run on our scene here, and you can see it already starts populating some script nodes here. And we will stop this Mel Profiler, and we'll go ahead and stop our playback. As you can see, it shows us some of the scripts that are running. Current renderer. It's actually obviously a script that's located. Let me expand this out a little bit. A little bit more. Well, let's just make this full screen. There we go. The current renderer script or procedure is taking up like 0.01 seconds percent of runtime. It gives us the time is 2 milliseconds. It's 2 milliseconds. The number of times it was called throughout that animation run. The total time, it takes 2 seconds, about 2 seconds to run it once, and the average call time, which is 0.113 milliseconds. The last column tells us the procedure location. It tells us the Mel procedure found in the base Maya application under supported renderers. This is actually just scripts that run within Maya by itself. We have the play forward button script, the playback state change script, as well as a UI res script that are also showed up in this profiler. If we wanted to run a particular script, you would literally go through and tell it to profile a script file, and it will ask you what script you want to profile. So you would just double click on it, and let's see if we can find one here. Actually, I don't have one handy, but that's how you would launch it, and it would show up and show you all the procedures in that script file as you run that script file the same way it does here. The save profile data allows you just to save the profile data, and then your call graph also can be saved also. So you can see that the Mel Profiler has a lot of the same functionality except for Mel scripts within Maya. The one thing that it doesn't have is the ability to profile your Python scripts. But we'll go into something here in a minute that shows you how to analyze and debug your Python scripts within Maya.